Lesson 8.4. Last lesson we talked about ways of showing how two triangles were similar so that we could use proportions to solve for missing pieces. In Lesson 8.4 we're going to show how we can prove that triangles are more than similar, and that is congruent. Now we talked about how it's one thing to be equal, it's another to be similar, but in geometry congruency is all powerful. That means they are the same shape and size. But they don't say equals in geometry, they say congruent when we're talking about shapes. We said yesterday that to show triangles were similar, all we needed was an angle and another angle. So we had the angle-angle postulate. And that allowed us to show similarity, which then allowed us to do proportions to solve for missing pieces. So today we're going to find out ways to show how triangles are congruent. The first two things we'll learn in this lesson anyway is angle side angle and angle angle side. Now below are all of them. We have side side side. Okay. We have side angle side, angle side angle, and angle angle side. Like as mentioned above, we're going to focus today on angle side angle and angle angle side. Notice there is no side side angle. I write it that way on purpose. Luckily for us mathematicians, that's not one of them to use. Angle side angle is written that way on purpose, and it tells you that you're given two angles shown to be equal. So here's angle T and angle G are said to be equal or congruent, and angle R is congruent to angle C. Then you have what's called the included side, the side that is between those equal angles. If you can show that situation, then you can show or prove through angle side angle that the triangles are congruent. Again, as well as angle side angle, angle angle side represents positioning. You have two angles that are equal in measure, but instead of having the included side, you have the side that's not included. So that in this case is this one. You could have the other one, but it's outside the two angles. And this is called angle angle side. If you can show that, you can show congruency. Here's a short little proof just to kind of show you that theorem 4.5 works. In theorem 4.5, again, numbers really don't matter. It just depends on the book. But we are talking about angle angle side. So we're trying to prove angle angle side. In other words, we're trying to show that that information is enough to show congruency. So they give us angle M being congruent to angle S, and angle J being congruent to angle R. And then they tell us a side, ST, and NP. So they start with the given. Then they show and say that P is congruent to T. Now, third angle theorem is basically coming from, that's the word that another book uses, but it's basically angle-angle postulate. Okay? And if you know an angle-angle postulate shows that two shapes are similar, it also tells us that the third angles must be equal in measure. Or triangle sum theorem is equal to 180. We use that as well if you remember from the last couple of lessons. So if you have two angles congruent, then the third must be congruent. And I would allow you to say angle-angle postulate. Now from that information, if you have angle P, that'd be this one then, and angle T equal in measure, that would be enough to show congruency. But how do we show congruency? How is it going to work? Well, we now have an angle, side, and an angle, which allows us to use the other theorem, angle, side, angle, to state that they are similar. Excuse me, to state that they are congruent. So we wanted to show that angle, angle, side is it shows enough for congruency. So we started out with angle, angle, side information. We used angle, angle postulate to show us that the other two angles are equal also. And then that gave us the angle, side, angle relationship. Now look at this next question. Is there enough information to prove that these are congruent? Now you need angle, side, angle information, or you need angle, angle, side information. We have two triangles. That one. And that one. I tell you that this angle equals this angle. This one's 90 and so is this, so you have two angles equal in measure. So you have two angles equal in measure, so you have to either have the included side, which would be this one, and this one, or excuse me, that's the included side, so this one or this one, but we have no way of proving that they're equal in measure. So this one won't work for us. But how about a side outside the angles? Well, that could be this side and that side, but again, we have no way of telling. But what about these sides? Now, this side is shared by both triangles, and because of that, they are equal in measure. In other words, this is called the reflexive property. The reflexive property just tells us that if one triangle has Pn and so is the other, that they are indeed equal. Sounds simple and strange, but it's the truth. They're the same side, so they should be equal. And the reasoning for that is reflexive property. So we can use, yes, so there is enough information to show congruency there. Now this is a big one. Corresponding parts of congruent triangles are equal, or corresponding parts of congruent triangles are congruent. You could put a C there also if you wanted to. Corresponding parts of congruent triangles are equal in measure. CPC TE. I will tend to say CPCTC by habit. Sorry about that. Now, next example here, I'm going to show you that you have this angle equal to this one, and this angle equal to this one. Now, is that enough to show congruency? Well, again, they share this side, so this would give you angle, angle, side, which is enough to show congruency. That's your justification. But the exercise is to have you name the pair of congruent triangles, because how you describe them is very important. And I'm going to end this part at this point, and I will finish the next couple questions on part B.